Okay, so for today's lesson, the title of these notes is a real-world refresher and the why behind real-world domain and range. So we're going to make a connection. Today's objective on the board says you'll be able to connect your knowledge of domain, range, interval, and set notation to real-world scenarios. So number one is our first real-world scenario. Please go ahead and take a minute and read this scenario to yourself quietly. Okay, so it says the height of a projectile launched upward at a speed of 32 feet per second from a height of 128 feet is given by this function. H of t equals negative 16t squared plus 32t plus 128. The sketch below shows the values for x that make sense in real life. So let's take a look at this graph. We clearly have only one quadrant of the graph. The object is being launched from the top of the building, and what does this represent in the real world? What would this be? This would be the ground. Good. So first we're asked to define variables. Raise your hand if you needed to define variables last year. 2, 3, 5. Everybody should have your hand up. You defined variables last year, but we're going to refresh your knowledge of how. So I have t and I have h of t. In this real world scenario, we have two measurable values. What can we measure here? What is this all about? Height is 1, very good. And feet. So now we need to decide, is feet t or h of t, and is height t or h of t? Height is h of t. Distance, good. So we're going to say distance. And how is distance being measured? What unit of measure? Feet, thank you. And that would mean that t is... Nope, we have height. The distance is feet. What's t? Nope, feet is height. What's t? Time. Measured how? The distance, you can say height or distance. Distance off the ground, distance or height.
So we always mention that.
We're always going to be defining variables. Now, if we notice, both units of measure are mentioned right there. Feet per second. We just needed to correctly identify where did feet go and where did seconds go. So when we're defining variables, always look for something that you can measure. Okay? Very good. Now, let's add these labels over here. So what label should I put on the x-axis? Ground. Do you see the word ground here anywhere? Time. T. If it helps, let's add these labels. Here's x, and this is going to be y. So on the x-axis, let's label time in seconds. And on the y-axis, we're going to label distance in feet. Now, we have two follow-up questions here. It says, why do the negative values of x not make sense? Well, we've established that x is representing what in this real-world scenario? Time in seconds. So let's ask the question again. If x is time in seconds, why do negative values not make sense? Time can't go backwards, except in the movies. So we cannot have negative time. So the reason is can't have negative time. And if we look at the graph, do you see any piece of the graph over here where the negative x values are? You see any graph? No, there's no graph here. Now let's figure out why do the negative values of y not make sense. What did y represent again? Distance in feet. Can we have negative feet? No, well, if something was underground, can something be underground? Yes. Good. So in this scenario, do we have something that's going underground? No. Right. Once it hits the ground, you're done. And what height is the ground? 0? Ground is at a height of 0. You told me that before, right? So once it hits the ground, it's done traveling. So in this instance, we can't have negative feet. If this scenario was something about an object being thrown down a well or a cave underground, sure. But in this case, no. And the graph, again, demonstrates that. Do we see this graph continuing down here at all? Look where I'm pointing. No, it stops. So we clearly have a restriction on my domain here. X values do not extend to the left, and we have a restriction on the range. Range does not extend below 0. So let's apply our prior knowledge. Can you please get me the set and interval notation given this graph? So here's my graph. What is my domain and what's my range? Which one are you trying right now, domain or range? Domain? Okay, go ahead, Lewis. Are you going to give me interval or set notation? You do. Nope, this one's for you, Lewis. Interval notation. Give me what, comma, what. You were right with the first thing you said. What's the first number I should write? 0. Because when I come in from the left, this is where my graph starts, and that is at 0 on the x-axis. Now, Lewis, what direction are you going to come in from? This side, the right side, and I stop when I hit the graph. Where am I on the x-axis? 4. Now let's commit to brackets or parentheses. What should be next to the 0? A bracket, and what should be next to 4? Good job. Now let's translate that to set notation. I have a curly bracket, x such that x is between 0 and 4. Most of us did a pretty nice job of this on the quiz. Remember that if we're saying it's a bracket, my inequality sign does need to have a line underneath. Who's got the range? David, go ahead. Come in from the bottom. If you pull 4, that's going to be an x value here. So when I come in from the bottom, if this is my starting point, I track it back over to the y-axis and I ask myself, where is this on the y-axis? And you're correct, it's at 0. So 0, comma, 140? Close. It's close. I agree. Well, that's not at 140. This would be like 130. But there's an ordered pair that's a little higher. So what's my largest y value? Good job. 144. Brackets or parentheses? Good, on both sides. So on your own, please write your set notation and then you can look up and compare with me, okay? In this instance, in this graph, yes, but we can't make a generalization that it's always 0, David. So go ahead and write your set notation. Do we match? Awesome. Okay, now keep what this graph looks like in mind because we're about to change it up and look at a new scenario. And the graph is going to look much, much different. The ultimate question is, why is the graph going to look different? The number of shoes in x pairs of shoes can be expressed by this function, f of x equals 2x. And that makes sense, right? Because if you have one pair of shoes, how many actual shoes is that? 2. If you have 10 pairs of shoes, how many actual shoes is that? Try again. 10 pairs of shoes, how many? Okay, we've established 20. Good. Try that. Okay, so let's decide how we count pairs of shoes. How do you count pairs of shoes? Don't get by ones, right? So you say that I have 1 pair of shoes, 2, 3, 4, and keeps going. And let's just make a note. We're saying domain is number of pairs of shoes. Yep, write the numbers. Because that's how we count, right? 1, 2, 3, 4, 5. And then we're going to say what subset would make sense for the range. What did the range represent again? Once you know how many pairs of shoes, what can you figure out? The actual number of individual shoes. So, number of shoes total. Shoes total shoes, individual shoes, however you choose to write that. So if you have one pair of shoes, how many shoes is that? 2. And you have 2 pairs of shoes, 4. So how would you count? 2, 4, 6, 8, 10. It keeps going by 2s. Okay, so let's translate this into the table. What should I put for these x values? 1. And my y values? Can you graph these points? Go ahead and graph them. So, well, what should I graph? You tell me. Is it going to be a line? Ooh. What's my first ordered pair? 1, 2. Good. Next. 2, 4. 3, 6. 4, 8. Awesome. That is the question. Do I connect these dots? This happened on the quiz where a lot of people were trying to connect dots for a graph that was given like this. I'm going to hold off on answering that question. We're first going to decide, why does it make sense to have ordered pairs instead of a continuous line? So just by the question alone, I am establishing that we are not going to connect those dots, but let's talk why. If I had an ordered pair, look where I'm pointing on the screen, like right here, what x value would this point have? Like 1 point what? I don't know, 1.5 or 1.4, could be 1.399. Can you have 1.399 pairs of shoes? You can either have 1 or 2, correct. So you can't have something in between. This would be like 3.21. Can you have 3.21 pairs of shoes? No. So, our answer, what should we write here? What can we not have? There's the word, decimal. Good. Can't have decimal pairs of shoes. So example, somebody give me a crazy decimal. 3.568 pairs of shoes. Doesn't exist. So let's all agree. Are we going to connect these dots? No. Now look at this graph, and then look at the graph that is given to you at the top. Do they look anything alike? No. I'm going to put label here, number of shoes for my y value. Okay, so how would if I asked you for the domain, what is the domain of this function? 1, 2, 3, 4. What's the range? Done. All I can do is list the points. There is no set notation, there is no interval notation. It is purely a list of points. So for those of us who struggled with this question on the quiz that I just passed back, don't overthink it. If I have these set ordered pairs, they are not connected. We are simply going to identify the ordered pairs and list the values. In order, least to greatest would be nice. Okay, let's start looking at number 3. We are going to work till the bell. I have a single real-world scenario to pass out to you for homework this weekend. As far as we get in the notes is as far as we get, and we'll finish on Monday. I do want you to try your absolute best to apply your notes to your homework. I have full confidence that you are able to try. Of course. Let's pass out the notes. This was just our warm-up. So like I said, can I have 2 volunteers to pass out the notes? Come on up. As far as we get in the notes is as far as we get today. The rest will be finished Monday. You should be able to use as far as we get in the notes on the homework that will be passed out at the bell. People who are waiting for their handout, go ahead and start reading this real-world scenario on the screen. Is anybody interested in scuba diving? Ever? Has anybody ever been? One person? Not snorkeling. Snorkeling is where you stay on the surface with the little thingy that's in your mouth, and you've scuba dived with like the backpack with the air and the, yeah? So this applies to snorkeling, which is when you dive with those backpacks of air on your back. Go ahead and read the scenario while you wait. Quietly. Okay, water pressure can be measured in atmospheres, where 1 atmosphere equals 14.7 pounds per square inch. At sea level, the water pressure is 1 atmosphere. So if you're sitting on a boat, you're not underwater, you're at sea level, that is called 1 atmosphere's worth of pressure. But it increases by 1 atmosphere for every 33 feet in depth. So every time somebody goes down 33 more feet, it increases by 1. Therefore, the water pressure can be modeled as a function of the depth d by this equation. And this is a real-world equation. Please put it in a box. We don't want to lose track of this equation. It's going to become very useful in a moment. Where d is between 0 and 130. So this equation contains the variable p and the variable d. There are 2 measurable quantities in this real-world scenario. Take a second, let's find them. I need to know what d represents and what p represents. So I've heard p is pressure. I agree with that. Ooh, good job. Okay, so p is water pressure. Let's establish that first. I heard that first. Water pressure. How is water pressure being measured? What's that word? It gives me a word here. Starts with an A. Atmosphere. PSI, I think, is pounds per square inch. And we will have real-world scenarios where that is a unit of measure. Here, it's going to be atmospheres. Atmospheres. It would be interesting to look up the connection, though, between atmospheres and PSI. I'm wondering how they're connected. Find that out for me. And D is going to be depth. Good job. Depth in feet. So again, every real-world scenario will always have 2 measurable quantities. It kind of was a giveaway, D for depth, P for water pressure. If this had said X and Y, I would hope that you would reason which do you need to know first. You need to know your depth to then know what water pressure you're experiencing, which is what makes depth my independent variable and pressure the dependent variable. Okay, good job. Now, here is our question. Determine the domain and the range. I challenge you to go back up to the question given and find me what's given. One of those 2 is actually given to me in my question. Who sees it? What do you see, Davian? Say that a little louder. Now, I'm looking for, yes, this is about water pressure, but I'm looking for the given domain. You see it, Davian? One more chance. True, depth matters. Pass this off to Jeffrey. What do you see? That's part of my formula. Keep this on the back burner. Something right next to it should jump out at you. Ooh, look at that. Right there. I'm actually going to put it in red. If you have a highlighter, highlight this. If you don't have a highlighter because you're going to get them over the weekend, box it, square it, draw arrows. This is what? That is my domain given to me in set notation. Bam. No work required. The real world scenario is giving me my domain. How awesome is that? In this case, no. I'm good. Good question. Davian asked if we need to do the curly brackets with the X and the bar. You can if you want to. I'll accept this. because now it's expected if I did ask you for set notation, you'd be able to write that. But we'll take just the inequality. Fantastic. But the question is, what does this actually mean in the real world? What is your depth? What's your smallest depth? Smallest depth. 0. Ooh, good question. So Jeffrey just asked if 130 is feet and 0 is atmosphere. This is only about depth. Remember that domain is all about which values? X, and range is about Y. So these are both depths. So 0 depth means what? Where are you? At the surface of the water. And what's your maximum depth? 130. So make a little note. Possible depth, 0 feet, and a max of 130 feet. And side note, this is really important for divers to know. That's in diving class, they learn about depths. Has anybody ever heard of the bends, divers who get the bends? B-E-N-D-S? Davion, do you know what that means? But you've heard of it. So divers, when they go, as they go and that pressure increases on your body, it actually affects the blood in your system, in your body. And if they come up too fast, you can actually get air bubbles in your bloodstream and you could die from it. So in an emergency situation, if a diver comes up too fast, they take them to a hyperbaric chamber. Has anybody heard of that? You should Google this stuff. It's really cool. And it actually, so like let's say they come up too fast, this hyperbaric chamber will actually imitate the pressure of wherever they came up too fast from and gradually bring their pressure back to normal. So divers, as they go certain depths, they actually have to know their math, come up a certain amount, wait a little bit. Come up a certain amount, wait a little bit so they don't suffer the effects of the bends. Yes, Jeffrey? Yeah. Yeah, your body, that would be pretty gross. Yes, I agree. So if anybody's curious, you can Google it. B-E-N-D-S, I'm pretty sure is how it's spelled. It's pretty cool. If you're interested in diving, you learn all about that. Okay, back to the math. Now, I know my smallest depth, which is 0, you haven't gone anywhere, and 130 feet down. But now I need the range. So while we contemplate this, let's add a little note. Domain was about depth in feet. It's always good to label this. And range was, what's range represent here? Good, measured in. Good. So label it. I label, you label. This is a good strategy to remember exactly what we're talking about. How am I going to figure out the atmospheres? I must be given something that I can use. There was something we said we were going to put on the back burner and bring back later. Yes. We've got this awesome formula right here. Have we used it yet? Guess what? We're going to use it. So, what x value are you going to plug in first? What's your smallest x value? So if I plug in my smallest x value, which is 0, that's going to find me the smallest. You plug in x, you get out y. So let's say let d equal 0, or we can say p of 0. That would be using function notation. So let's do that. We're going to plug in our smallest x value to find the smallest possible y value. So that is going to look like p of 0 equals what? .03, good, times what? 0. Oh, careful, we're plugging in 0. So that's why I want you to give your work this title. Choose this or this, but I need to see it. Yes, function notation, we're going to, wherever we see our input, we're going to plug in a 0 plus 1. Anything times 0 is what? Careful, good, 0. And then plus 1 equals, not a trick question, 0 plus 1? 1. Okay. We plugged in our smallest x value and found the first value of the range. Guess how we're going to find the largest possible y value? What are we going to substitute in? We plugged in 0. Look what we plugged in. We plugged in 0 and got 1. Now I'm going to let D equal, there you go, 130. And that will find me my largest possible Y value. So let's do it. P of 130, and this is where a calculator is needed. Let me know what you get. I hear a vote for 3.9. Do you guys agree? Plus 1. So 4.9. Don't just watch the math, try the math. Use your calculator right now. It's 0.03 times 130 plus 1. 0.03 times 130 plus 1. 4.9. I'm hearing some yeses on this. Good. Good. So we have found what we need for the range. Now we just need to put it all together. So P is greater than or equal to, what was the smallest? 1. And less than or equal to, there we go. There's my range. So I was given the domain, and our new skill for today is learning how to take the given domain and actually calculate the range. Awesome. Any questions on number 1? Okay, let's apply this new knowledge to number 2. During an epic snowstorm, it was snowing at a rate of 4 inches per hour for 5 hours. This can be modeled using this function, y equals 4x. Again, let's define our variables first. Good job. X is hours. And once you know how many hours have gone by, what do you know? Good. I like it. Okay. Now, in number 1, I was given a numerical restriction on the domain. I saw numbers for a restriction. In number 2, I have a written restriction on the domain. Can you reread number 2 and find me the restriction? Reread it and find it. That's my equation, so we'll put that in a box. We'll save that for later. But there's something I'm told about how long it's going to snow. There you go. Highlight it, box it, square it. Do whatever you need to do to make sure that stands out to you. Highlighter's the best. So if you don't have highlighters, bring them in for Monday. 5 hours. Good. Very good. So I ultimately want a graph, and your homework is going to have a graph on it. So we need to pick some points here. It makes sense to pick my smallest and biggest. What's my smallest possible x value? Smallest x value. What does x represent again? Hours. So think real world. What's the smallest possible number of hours? Less than that. Ooh, I heard it. No hours would be 0. So let's choose 0 as a point. And then what was the restriction on the time? 5. How are we going to figure out my y values? But I need the numbers. How do you figure out what the y values are? We put it on the back border. Back burner. Yes, my function. So let's figure out f of 0 and f of 5. Let me know when you have them. So what's f of 0? I'm using this function. That's where it's coming from. Okay, good. Remember function notation from last year? So make a little note. We'll be seeing it more and more. Y and f of x mean the same. Remember that? So we're bringing back function notation. Good question, Lewis. Lewis asked, where did f of 0 come from? Because he saw a y right there. That was a good question. Remember, the output y and f of x, they mean the same. But this keeps track of what I plugged in, because now I know what am I plugging in. 0. So 4 times 0. And then here, Lewis, what am I plugging in? Good job. I'm substituting in a 5, and I get 20. Where? F of 0 equals, I just put a line down my equal signs. This is a 4. Sorry, it's a little tight. Let me fix that. There we go. 4 times 0 is 0. Great. How many points do I need to graph a line? 2. Do I have 2? Yes. So let's get some labels on this graph. How should I label this? Ooh, careful. Time in hours, or number of hours, whichever. And then what's over here? Good. Height in inches. Let's count by ones, and we'll skip a line. So 1, 2, 3, 4, 5, 6. I need to get to 20, and it doesn't look like I have 20 lines here. What could I count by here? Well, maybe, let's see. 1, 2, 3, 4, 5, 6, 7, 8. How about we count by 2s? Oh, well, who thinks we can make it? Let's try ones. So if this is 1, we'll put a 2, 3, 4, 5, 7, 8, 9, 10. I can't, right? So what should I count by? Can I try 2s? Let's try 2s. So if this is 2, this is 2, 4, 6, 8, 10. We can label every other. Does that make sense? 12, 14, 16. Ooh, that'll work, right? 20, 22. So 0, 0. Ah! Who saw the mistake I just made? Who's got it? I totally skipped 0. Oops. So shift these up. Should be that. Okay. Whew. That was a close one. Okay. 0, 0 is right here. And 5, 20. How am I going to graph 5, 20? Where do I go? You know. How do I graph 5, 20? Right 5. Up 20. 18, 20. Right there? Now be careful. Think about this. How should I draw this line? I'm going to start here. Do I keep going? No. Where do I stop? Right here. Why do we stop right there? Why am I stopping right there? Why we usually just keep going and going, right? Why do I have to stop right there? But why is there no arrow? I'm having some serious graphing issues here. Let me see. 10. Oh wait, no, I was fine. The line in between represents the... I think I just shifted it a little too much. The line in between represents the 12. 10, 12, 14. Good question though. Do we see that now? Okay, good. So back to the question, why did I stop right there? Fantastic. How long did it snow for? Only 5 hours. So was it snowing during the 6th hour? Nope. So that's it. Very good. Let's decide on our domain and range. And if we know what we did up here, if we understand what we did up here, we actually already know our domain and our range. X is between what and what? Very good. X between 0 and 5. Or if you would like to give me interval notation, I'd be good with that too. And who's got my range? Awesome. Let's talk about why this is right. What did domain represent again? Number of hours. And what did range represent? Height in inches. At 0 hours, how much snow is on the ground? 0. We calculated that using our formula by plugging in 0, and the output was 0. At 5 hours, which was the longest it snowed, when we plugged in 5, we calculated how much snow max. Would it be? When I plugged in 0, what did I get out? So the question on the table is, wouldn't this be 5? Let's talk about that. When I substituted in 0, what was the output? So Jeff, look up here. We use this formula, right? When I plugged in 0 for x, what did we calculate? 0. Okay? So, hold on. 20 makes sense. What did 20 represent? Maximum number of inches. Fantastic. So you're going to use the warm-up notes and these first 2 examples to do tonight's homework. Come on up and grab it. Have a great day. No, we're going to finish the packet on Monday. Do not continue in the notes. Come see me for your homework. Happy Friday, everybody.